Hi, this is Michael Oriana. We're going to talk about how to produce ceramic um, plates in Rhinoceros. Rhinoceros is a very interesting modeling tools for designers. You can have it, you can install it in your computer, either PC or Mac. So this is a paid it's not very expensive, but it is about $200, $300 for students, for scholars or for people in general is about 1,000 and above. So first you need to have a 3D model. Let's start with that. A 3D model of a ceramic. We are not going to talk about how to produce a 3D model with a laser scanner, neither with how to refine this model. We're gonna only talk about how to produce a plate based on a 3D model. That's all. So we have this 3D model. I scan from using a 3D scanner. Let's see, it's coming. Let's wait a little bit. My computer is a little bit slow today. So this is the environment of Rhinoceros. Obviously, you see what you are seeing here is the plate already done, but we're gonna delete this so you can have an idea of how to produce from scratch, how to produce this plate from scratch. So I have this 3D model of the plate here. Now it is very important to export these 3D models in a format that this app can open. So STL is the extension name of the correct format, the appropriate format for this app to be used. Okay, so don't be scared for all the different icons that you are seeing in this app. We are not going to use all of them, but basically the ones that we're going to use mostly are already designed so you can use it in a very easy manner. What you have here at the top here is how you see a 3D model. If you want to see just the right side, you click there, the front side, the top side, and as a perspective. You can change the view just by dragging or using your mouse, and you will change the perspective of this mesh, this 3D model. So, as you know, a basic principle to determine a correct stance of a ceramic is by finding a common way of doing finding the correct stance of a ceramic is by pressing the lip of the ceramic, which is this part, against a table. If you do that, you will be able to see what is the correct stance of this piece, of this particular piece. So what I have done is I combine this basic principle with a function in this program that is there is an additional app that is called Grasshopper, and it works with Rhinoceros. It's an app that produce mathematical calculations and produce other type of automatizations. So you call that app by typing here Grasshopper, just as I am doing here. You click there, you type it, and it will come. You wait a little bit and it will come. And trying to simplify a very complex process, so don't worry. What you see here is several components that were not finished the last time I opened Grasshopper, so don't care, just exit. Okay, so now what you're seeing is here at the center, all these green boxes are the different functions that I created. I created mathematical calculations for creating a plate. Now the version that I'm gonna share with you is the 2019, because since then I improved this method several times, but this is the one that I'm gonna share with you. I'm gonna teach you how to use it. So don't worry about the complexity of what you're seeing there. It's not that as complex as it seems, but you will be able to interact. So you have this environment first, that is Rhinoceros. This is Rhinoceros, and you have your mesh here. This is your mesh, and you have this another app that is inside Rhinoceros, and it's called Grasshopper. As you see, if you click your app here, Rhinoceros, you will see the name Grasshopper here. So you go back again here, and you will be able to see it. So what you do is this app, I created this app already that makes all the mathematical calculations to produce a plate, so you don't need to worry about deciding which is the correct stance of a particular ceramic. But it's not perfect. It's I would say it's a very accurate way of producing plate, but still it's a work on progress. Still, I am perfecting some aspects of it. I would say it has a margin of error of maybe 1%. It wouldn't work for 1% of the ceramics that you are trying to produce, you are trying to work with. So we will see special cases later, but for most cases it will work perfectly. 90% it's an estimation, obviously, but I think 99% is pretty accurate. Okay, so in first place plates, you will click here, and you will do right click, and you will choose the option select one mesh. So what it does is it will force you to select the mesh that you are working with, which is this one. So you go back to that view, and you select the mesh. Now you're seeing the mesh in green. So that means that this mesh has been selected. Okay, so now the mesh is selected. It's good. Now you can work with this mesh, because now you can produce mathematical calculation. Let's see. Don't worry about the mathematical part. It's already solved. Now you go back to the app here, and then you see this title here. It says 3 points. So what it does is you have to select the 3 points that are at the top of the lip. One in the center, one in the left, one in the center, and one in the right. Viewing the ceramic from inside out, as if you were facing the ceramic from the center of the radium of the vessel, of the center of the vessel. So let's see how that works. So I have this point, I right click here, and then I set 1 point. So I choose this option, set 1 point. I click there, and I go back to my mesh, which is again here, and what I have to do is select the left point. on the lip of the vessel. So that will be the upper, the most highest point on the lip of the vessel. I think that should be here. Now, it works two ways. Sometimes, if you're not able to see the lip of the vessel very well because probably you have some doubts, maybe the ring is kind of broken and you don't see the lip of the vessel quite well, you can trust on any circular or circumference that is visible on the vessel. Usually the potter, when he works with the clay, he leaves some traces of his work with his fingers on the clay, and usually those marks are circular, so you will see them very clearly. And in some cases, in this case, we are very fortunate to have the lip, which is very clear here, and it's obviously a part of the vessel, of the circumference of the vessel. So I click here. This is the left point, the highest point in this ring. Because if I, how do I know that? Because if I posit the ceramic in this way, I am able to see and deduce which is the highest point. I could use any other part of the vessel that has a circumference. So, but it's much better if you choose the highest point on the lip of the vessel. Okay, so I just choose the left one. Now I'm gonna choose the center one. So I have the center one here. Again, I right click there and then I click set one point. Now I choose the center part of the vessel here, of the lip of the vessel. So you see what I am doing is trying to follow the circumference of the lip. I wouldn't do that over here. I am trying to follow the circumference of the lip. So I click here and then here, which is an estimate. Obviously, it doesn't have to be perfect choice, but it has to be an estimate. An estimate. That's good enough. Now I do choose the next one, which is the third point. Here is the right point. I click here, set one point, and I go back to my mesh and I select the right point. As you are seeing, I am looking to the ceramic as if I were at the center of the vessel. I am seeing the ceramic from this point towards the lip of the vessel. That's why I'm saying the left, the center, and the right. So once I choose these 3 points, now most of the work is just done. Yes, quite easy, right? So you will see here, it says final drawing. And I click here, and let's see what happened in my ceramic. You see here that what happened is the mathematical calculations of what is the correct stance based on those 3 points that I choose is already done for me. I don't have to do all the hard work of deciding which is the correct stance of the drawing. Just by choosing these 3 points, the app that I have written calculates the correct stance of the vessel. So that's very fast, because now what you're seeing in the drawing is the right part of the vessel with the projection to what will be the radio, the left part, and so on. So there are some corrections that I made in the last version of this. In the last version, even the center line goes only to it goes only to the bottom part of the vessel. It doesn't go all the way to here. And what you find here at the very bottom is the scale. This is the scale. This is this is 10 centimeters. Each one of these boxes is each one of these rectangles here is 1 centimeter. So you can have the estimate, or you can make the calculation of everything here. Additionally to that, I make all the reference here, but I don't want to go too deep into this. So just making a review there. What I have to do first place is I have to select 3 points on the lip of the vessel: the left, the center, and the right. Once I have chosen these 3 points, you go back to my app, and my app, just by clicking here, is gonna tell you what is the correct stance of the vessel. That's all. Now you need a drawing. So what do you have to do now? You just click here, final drawing. It says here, final drawing to produce, and you do right click there, and you click here, bake, and then you click OK. That's all. So your drawing is ready to be collected. So you go back to Rhinoceros, and let's see. You see all the green, that's the drawing. So what happened is I have first to unselect this box. So I click outside the box, so it's no green anymore there. And I go back to Rhinoceros, and then you see the drawing here. This is the drawing. It's the drawing made based on the 3D model that I have chosen. Yeah? Ready to be collected. How long, how much time did it take to produce this drawing? Almost nothing, right? Obviously, once you export this into Photoshop or any other drawing design app, you will have to do some edits, because this is the first version of this app that I created, which has some corrections to be done. For instance, you have to shorten this line here. You have to fill this part of the vessel with black, and probably you have to thicken a little bit some lines. So few corrections to be done, but most of the work is done. The app that I use for doing all these edits is Photoshop. Is Adobe Illustrator. That's the app I use. But that's another lesson. So what I wanted to do now is just to show you how quick and easy it is to produce a ceramic plate using this method. If you can scale it, if you can do it in a greater scale, you have several meshes and scans already done, you can advance pretty quick. So that's it. And I just want to say that you also have instructions here that are self-explanatory. Okay, I hope that helps you to understand how this app works. Obviously, there are many details, but I think those have to be thought in a more complete manner, probably with a larger session. I hope that gives you an introduction to this way of doing ceramic plates. Thank you. Have a wonderful day. If you have any other questions, you can send me an email, And my webpage there was at the beginning of the video. You can get registered. Everybody who gets registered can have access to this app, and that I created. But the rhinoceros, you have to buy rhinoceros by yourself. This is and I can teach you how to install that probably in your computer if you're interested on that. Okay, have a wonderful day. Bye bye.